All right, this is task number 4 for coding Corona, which is your epidemic model. This is actually the last project in SL Nova that you're going to start for my class because the next tasks 5 and 6 and even 7 are all based on the same epidemic model. In fact, in addition, there's no coding for this task whatsoever. We're just taking colliding turtles, which was task 2, which had to do with those conditionals that we use, those yellow blocks, and applying them to the research that you did in your data dive, which will eventually make our epidemic model right now. So if you're looking at mine right here, you may notice I have lots of blues, a good number of yellows, and a couple reds. In fact, I think I got 3 or 4 reds here. And my whole setup is to the model of the United States. Now I'm going to ask you guys to do the same thing in probably about a minute. This shouldn't take more than about a minute, maybe a minute and a half, to explain your background of your population. Now, to be more specific, you can take a look at the link that I have in our weekly tasks. I also have a slide on our Coding Corona PowerPoint. I think it looks a little bit better here, though, so I'll start here. But your goal is to take your data dive, again, see the examples and from your data dive, and then set up your code to do your research. This means using like math to create your proportion. And you may remember in my model, I used 330 turtles, and that was for the 330 million people in America. And I set up 312 healthy blues, 5 red corona infected, 23 yellow immune, and 1 black or dying or on a ventilator from corona. And I didn't make these numbers up. This is from my research. And just another suggestion, and I want to make sure I write this down for you guys, suggestion. Don't have more than 500, that's probably even a lot. I'm going to say 450 turtles or agents in spaceland. It gets pretty crowded if you put more than that. So my suggestion, let's not overcrowd spaceland. I'd say keep it to 400 max. I'm using 330. And I'm using 5 red because even though we've tested positive for corona less than 1/3% at this point in time, we're in May, for coronavirus, I still believe the population is a little bit higher. So I'm doing about 2% with 5 red. And I do believe there's as high as 7% of immune coronavirus carriers in the United States, not because of already being infected with an antibody, but because they have genetic immunity similar to those with CCR5 or Delta 32 with some of my research on survivors of the plague and Black Death or other diseases of the past. So I think there's some that are going to be immune, and that represents my 23 yellow. And I'm going to have 1, even though that's still a high percent, I just want to have 1 black to represent the people that die or that are extremely sick on a ventilator. Even though it's really smaller percentage-wise, I just want to have 1 to represent them. But you must have the same conditional from your task number 2, which means your colliding turtles, if you remember right, you were to have your red agents, or if your red agents ran into a blue agent, then the blue agent turns red or becomes infected, and that's the whole idea. And please keep to the same color scheme, blue being healthy, red being infected, yellow being immune, and black being dead or dying or on a ventilator or extremely ill. Also, take a look at Q. She's going to have an example too coming up here soon. And my suggestion, I give you a tip. Let's try zooming in and out. Something when you guys are working on your videos, I'd love if you figure out how just a little zoom here or there and moving it around. Maybe there's something you want to show on spaceland, maybe not. But just test out and play with zoom in your videos. For Chromebook, I think are the tips there. And lastly, I suggest you write a 16-sentence narrative for this. So this is your write-up. Yeah, it should be about a minute, maybe a minute and a half of your final presentation, because your final presentation is a total of 3 minutes. And you probably already have some good idea from your data dive what you want to include, so it shouldn't be anything too new. But always good to keep in mind a rough draft and to add to it. So that's what we're going to be doing over time, is continuing to add to this rough draft for your total 3-minute presentation. We're probably just going to do about a minute of the background portion now. And you're also going to share that with Q and Poggio later. Make sure you put your name and title on it. And last thing I'm going to say, I'm going to toggle back and forth here with my data dive. So I'm just going to leave my camera there, but I'll reference my data dive here. Most in particular, the one that shows here, the 12% of New York that already had coronavirus, which was a more recent article and finding for the 15,000 that were tested for antibodies. So with that said, if I were to model, I would set up my spaceland and I would start by saying, all right, here we go. Well, I have 312 blues because that represents the healthy. I also have 5 reds that started out because that represents the infected at about a couple of percent after the first big wave of the coronavirus in the United States. And when my reds become in contact with the blue, as you're noticing, they're going to change color to red, representing the spread of the disease. So that's the conditional that I have coded in my code. And I'm not going to show you that. You could go ahead and look at colliding turtles, number 2. If you're having trouble with conditionals, if red runs into blue, then blue turns red. And you're going to see we don't have a recovery or anything like that. So eventually in my model, everything should turn blue. You don't need any other conditionals because our next tasks, which are task 5 and 6, we're actually going to do a procedure call to ask the red to turn yellow because anybody who is infected has a 99% chance of recovering and becoming yellow. So we're going to be able to do that in the next model. In addition, we're also going to add sliders, which will change the infection rate. So when we have things like, for example, social distancing or quarantining or other methods of trying to slow or increase the spread of coronavirus, we can actually change that transmission on a slider without running our code. So you'll see my model's pretty much all red here. Again, I could set it up and run it over again, but I'm starting with 312 healthy people in the United States, which represents about 312 million. And I said there is going to be a large percent, up to 7%, I think it was 25 yellow, that are immune because they have genetic immunity. And I started with 5 red, and you can see already that the reds are coming in contact with the blue, and the same pattern, of course, in my epidemic model will happen again, what you just saw earlier. So you're going to make a 1 to 2 minute video. I just wanted to explain this in depth. You saw all of the assignments that you can use to help you out. There's absolutely no code with this model. You're just setting up and starting and hopefully toggling back and forth, because your data dive, like I had mentioned with the antibody test from New York, should be some data that can help, and we would like to have you share in your final project. So that's it for task number 4. Good luck for setting up your epidemic model. This is the last project you'll set up in SL Nova because we're just going to add from it from here. All right. Good luck, Blackhawks.